video we are going to discuss about the structure of chitin. What is chitin? It is a polysaccharide. Chitin is a structural polysaccharide. Chitin is a structural polysaccharide because it strengthens the cell wall of fungi and it strengthens the exoskeleton of insects. It strengthens the cell wall of fungi and it strengthens the exoskeleton of insects. So it is a structural polysaccharide because it is involved in the formation of the cell wall of fungi and in the formation of exoskeleton of insects. And it is waterproof. So it prevents the water loss from the body of the insects. It is waterproof. It prevents the water loss from the body of the insects. Like cellulose, the chitin also a polymer of glucose. Here the monomers are N-acetyl D-glucosamine. The monomers are N-acetyl D-glucosamine. That is, it is a long chain polymer of N-acetyl glucosamine. Long chain polymer of N-acetyl glucosamine. And these N-acetyl glucosamines are linked by beta-1,4 linkage. These N-acetyl D-glucosamine units are linked by beta-1,4 linkage. The N-acetyl D-glucosamine are the amide derivative of glucose. It is an amide derivative of glucose. Amide derivative of glucose. It is an amide derivative of glucose. And the molecular formula of chitin is C8H13O5N N times. C8H13O5N N times. It is a polymer of N-acetyl D-glucosamine. Chitin is the second most abundant polysaccharide in nature. It is the second most abundant polysaccharide in nature. Let us see the structure of chitin. This is the structure of beta-D-glucose. Beta-D-glucose. If this OH, if the OH in the second carbon is replaced by the amino group, the OH in the second carbon is replaced by the amino group, it is known as D-glucosamine. D-glucosamine, beta-D-glucosamine. If this NH2 or to this NH2, if an acetyl group is attached with the removal of one hydrogen, that is known as N-acetyl D-glucosamine. Now this is the structure of N-acetyl glucosamine. N-acetyl D-glucosamine. So first the OH group of second carbon is replaced with the amino group, that is known as glucosamine. Glucosamine NH2. If with the removal of one hydrogen from here and adding one acetyl group C double bond O CH3, that will be N-acetyl D-glucosamine. Chitin is a polymer of this N-acetyl D-glucosamine. This is the structure of the first N-acetyl D-glucosamine and this is the second N-acetyl D-glucosamine. Here this structure, the second structure is inverted. The second structure is inverted to form the alpha-1,4 linkage. Beta-1,4 linkage. So let us see that this is the first carbon, this is the second, This is the third, fourth, fifth and sixth carbon in this molecule. At the same time, here in the second structure, it is inverted. So this is the first, second, third, fourth, fifth and sixth. So these two molecules combine together with 1,4-glycosidic linkage at the 1,4 carbon, but the first carbon of the first N-acetyl glucosamine and the fourth carbon of the second N-acetyl D-glucosamine. So the linkage is the removal of OH from one position and H from the other, and removing water and forming a bond like this, forming a bond like this. This is beta 1,4 linkage. This is beta 1,4 linkage. So the N-acetyl D-glucosamine units are linked by the beta 1,4 linkage in the structure of chitin. Now the third alpha D beta D glucose, the third beta D N-acetyl glucosamine, beta D N-acetyl glucosamine is again like the first molecule, first, second, third. So here the CH2OH is in the upward, here in the downward, again in the third molecule is in the upward, and the bond formation is in between these two. So with the removal of water, a bond, beta 1,4 bond is formed like this. So the first bond is like this and the second bond is like this, beta, this is also beta 1,4 glycosidic bond. So in this way, number of N-acetyl D-glucosamine molecules combine together to form chitin with the removal of several molecules of water. So by using the N-acetyl D-glucosamine molecule, chitin is formed. So in this structure, the first molecule is usual molecule, the second one is inverted, and the third one is the usual molecule, and the fourth one is inverted, like that. Number of times the N-acetyl D-glucosamine repeated to form the chitin. This is the structure of chitin. If this structure is arranged in parallel chains, if these two structures are arranged as in parallel chains like this, hydrogen bonding will form in between these. Hydrogen bondings will form. So the hydrogen bondings will form. So the cross-linked chitin molecules forms bundles. The cross-linked chitin chains forms bundles, which makes stronger microfibrils. So straight parallel chains of chitin molecules form hydrogen bonding. So cross-linked chitin molecules forms bundles. These cross-linked chitin molecules forms bundles. It makes stronger microfibrils. If the chitins are arranged in parallel, that is, they are straight chains, long straight chains. If they are arranged parallel, hydrogen bonds will form in between these parallel straight chains and forming bundles. These bundles make stronger microfibrils. These microfibrils strengthen the exoskeleton of insects and strengthen the cell wall of fungi. This is about chitin. Thank you.